Welcome back, friends. Please remember on this channel I post more advanced or interesting or non-routine math stuff. Okay? So here we have the integral from -3 to 3 of the maximum of x squared plus 2x2 minus x. We're going to find the value of this. Notice that our integrand has in it the math function, the max function rather. We have to somehow understand which of these wins the race for being the maximum as we go from 3 to +3. So here it really helps if you do a sketch first, okay? So I want to make sure I do my sketch somewhat right, so I'm going to put that all the way down below right here. This is going to be our x-axis. All right, let me draw in the y-axis roughly in the middle here, this way. Okay, so y, very nice, x. Now let's decide on what we mean by 1 unit. So I'm going to take this piece of chalk to be 1 unit. It's a little bit arbitrary, but it gets the idea across. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's stop at 9 right there. Let's also count this way. So this is 1, 2, 3. Let's go over here. So 1, 2, and then 3 this way. Let's label these a little bit. So this is -3, -2, -1 about, and +1, +2, and +3 this way. Okay, so now let's understand what happens with the x squared right here. We're going to focus on that part. Okay, I'm going to use pink to represent this because we're going to have 3 graphs so we don't want to get confused. So x squared, as I'm sure you know, for example, it goes through 0. When 1 goes in, 1 comes out. When 2 goes in, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here, 9 will come out. So 1 in, 1 out, 2 in, 2, 4 out. So where are we here? Somewhat carefully, right? And then when 3 goes in, we get, let's be careful now, 9 out. So roughly that's about here, this way, okay? All right, so we're going to have a piece that goes the way we've sketched it this way. Let me just kind of zoom out a little bit on the view here. I need to straighten this. So let me do that right now. Okay. Well, it doesn't have to be perfect. You get the idea though. Okay. So now, same thing over here. -1 in, 1 out. -2 in, 4 out. So let's say that's about here. And then -3 in, 9 out. So eyeballing it a little bit. Okay, that's always, there you go. Gets the idea across. That's our x squared. So this part is complete. Now let's use green to represent 2 plus x. So 2 plus x, what does that look like? Well, when x is 0 and 2 plus x, then you have 2. So you're basically here. And then when x is 1, then this is 3. So you're basically, say, about here, right? And when 2 goes in, 2 plus 2 is 4. So you're about here. And when 3 goes in, 2 plus 3 is 5. So you're about, say, here, this way, okay? That's that one. So the green part will be the 2 plus the x in this position. And let's see, let's go through -2 on that side. You see -2 going in, 2 plus -2 is going to be a 0. So we know it's basically going to do something like this, right? It's going to go this way. Okay, let's do one last one here. And for that one, I think I will use purple just to separate things. Okay, so that's done. Now let's focus on 2 minus x. Again, so when x is 0, you're back at 2 right here. Okay, when x is 2, 2 minus 2 is 0. So that means you're crossing the x-axis. And let's say at -2 is 2 minus -2, which is 4. So basically it would be at the same point, say, let's see, about here. And then when 3 goes in, 2 minus a -3 is a 5. So again, for that one, you would be about, say, here, roughly speaking. Okay. So the graph then ends up looking like this, just more or less gets the idea across. Now we have to decide as we go from left to right, from -3 to +3 this way, which wins, because that will then allow us to construct the integral. Well, over here it looks like x squared wins, right? It's higher than that. Let's see, the 2 plus x definitely, which is all the way down here, and it's higher than the 2 minus x, which is this one, right? It's right here, it's the biggest one. So then they intersect. So let me just label this. Remember, the purple curve is 2 minus x, right? So they intersect right here. So that means whatever the x coordinate is here is the solution to 2 minus x equals x squared, like this. That's solution. There are 2 of them, but we'll just take one and say the -1. Now we can solve this equation, or we can just tell by examination of the graph carefully, right? That's just equal to -2 right there. Okay, so let's start constructing the integral in a bit of some detail. Okay, so applying the meaning of the max function, I'm going to integrate from -3 to -2 this way, -3 to -2. And the one that wins the race from over this little interval right here, that is the x squared function. So you're going to integrate x squared for that reason, you see? According to the meaning of the max. Then, well, you can tell that, for example, from -2 to 0, the one that wins the race, the maximum, is the purple curve, which is 2 minus x right here, right? 2 minus x. So there you would construct another integral that says you're going to integrate from -2 up to 0, and the winner for the max function is our 2 minus x right here with the dx. Okay, let's continue. Now, look at what happens on the right side here. You're going to go from 0 up to 2, like this interval right here. And there, the one that wins the race is not the purple one, not the red one anymore, but the green one, which is 2 plus x. So you're going to basically add another term to be integrated here. So you're going to integrate from 0 to 2, and the integrand will be the 2 plus x dx this way. All right, and then the last one, again, from 2 to 3, we've seen that x squared is back to winning the race. It's the highest one, it's the maximum. So that means we're going to attach one more term here that says the integral from, let's see, 2 to 3, and this is x squared dx. Now here we would like to simplify this if possible in some fashion. That means specifically use symmetry. Hopefully you can tell that whatever we find, for example, from -3 to -2, and whatever that is, more or less right here, okay, like that would be copied pretty much exactly the same way on this side, you see? So we have that nice symmetry pretty much. So we can just take one of these as follows. Let's take the one that goes from 2 to +3 for the sake of simplicity, x squared dx, and by the symmetry here, just double the result, so multiply by 2, and then basically, right, this takes care of this term right there by doubling. Okay, so now, can we do something with those two? Well, again, let me see whether I can maybe choose a different color still. It gets a bit crazy, but if you integrate from -2 to 0, it's about the same as from 0 to 2, right? Like, if you look very careful, you see it's kind of this right here. Okay, so I'm going to kind of shade over it. It's about that region, isn't it? More or less. So that means you can say you're going to integrate for the sake of simplicity from 0 to 2, and then just take one of these, like 2 plus x, for example, and then dx this way. And then just double the result, of course, in the middle. So put +2. Now we have a 2 as the multiplier, so 2 outside, and then we have this integral from 2 to 3 of x squared dx plus the integral from 0 to 2 of 2 plus x dx. So to finish up, if you compute this, you will see that it's equal to 74 over 3, and that's the answer. Like this step right here, this is elementary, right? But at least this is a bit more interesting. Friends, please be sure to leave a like and subscribe if you're into mathematical content of this somewhat perhaps unique nature. I'll see you in another video.